So we've heard about wind, we've heard about solar, we've heard about microgrids, we've heard about flexible PPAs, storage, energy storage. Now we're going to get the update on the economics and the applications of energy storage for mines. Mike Grunow is the Vice President of Marketing for Vision Energy Systems. He's a seasoned commercial executive whose career encompasses over 15 years of commercial sales and marketing experience in the global wind, solar, energy, and energy storage markets. He joined Vision in February 2016, and prior to that, served as the Vice President of Marketing and Sales for Moventus, where he worked with the world's largest utilities to enhance the profitability of their existing wind fleets.
Lewis was up here really talking about the key challenge, and this is really the second year that Vision has been here talking to this audience, because while Lewis and his team are solving a big issue with respect to the disparity between the economic life of a renewable energy generating asset being 20 to 25 years, and the economic planning horizon of a mine being in the 5 to 7 to 10 year horizon, depending upon where it is in the project life cycle. What I'm going to talk to you a lot about today is energy storage. I'll be talking about a specific flow battery technology. I'll be talking about how it compares to the entrenched incumbent lithium ion, how it creates similar value to that redeployable and redispatchable solar system you just saw. And then we're going to get deep into a case study about a specific mine that we've been looking at together with our EPC partnership and EPC partner CMI, who's here today and is able to offer turnkey competitive quotes for systems like the ones we'll be outlining here today. A little background on me. So these first few slides here are really the I feel your pain slides, but we've been doing that for 2 days, right? It's really all about the CapEx and the APEX and the loud and the dirty and the whole challenge with high duty cycle diesel genset. So I'm frankly going to skip it because I'm between you and lunch and wherever you have to go for the rest of the day. Life of mine. Right? I mean, it is a real economic challenge. My grandfather was in the mining industry, and I had the opportunity to travel around the world with him when I was a teenager and visit some of the mining sites that he had either as an executive for Martin Marietta Corporation acquired or sold back in the 40s, 50s, and 60s. And the most memorable day of that trip was when we landed in a now ski town in Colorado called Telluride. He remembered how long before they put up the first ski lift, it was transacted to another mining interest after 3 or 4 years of exploration, and he was just kicking himself because now it's a multi-billion-dollar ski resort, right? So these things have a life of their own, and they have a life of mine, and each economic activity and each economic step has its own decision-making horizon that needs to be taken into consideration. But there are huge rewards, as we've discussed, right, with integration of renewable energy, and I think the rewards are best summarized as financial and environmental. And as we look into the case study and as we look into the vision technology, I believe that it's transformational and it has the ability to generate significantly more financial and environmental rewards for customers like yourself. So Vision is here today as the largest flow battery manufacturer in the world. We're a 10-year-old company. We're currently building the largest flow batteries in North America, Central America, India, and Europe. The battery itself, what you're looking at there in the lower left-hand corner, is a 1 megawatt block. That's a 4 megawatt hour assembly. It's made of commodity materials. It's basically made of rotomolded plastic tanks. It's made of shipping containers, standard off-the-shelf pumps, standard off-the-shelf PVC plumbing, and then those stacks, which are each about 20 kilowatts apiece. These batteries are made up of zinc and iron chemistry. They ship dry. You fill them locally on site with locally sourced water, zinc salts, iron salts, and KOH. The exact electrolyte is non-toxic, it's non-flammable, it's non-explosive. In most counties in the United States, you can legally put it down the sewer. It has the same environmental characteristics of Purell, that stuff you rub on your hands, you know, in the wintertime so you don't get a cold. And so it's environmentally benign, so it really helps with the permitting, the safety, and the overall environmental health and safety considerations that you may have in any mining environment in some remote community. It's a 20-year battery, meaning, and this has been verified by Black & Veatch. We've got this Black & Veatch independent engineering assessment. It's 73 pages. It'll put you to sleep, but it basically says the battery works and it'll last for 20 years and it'll do what we say it's gonna do. It's manufactured exclusively by Jabil. Jabil's a $19 billion third-party contract manufacturer, the second largest one behind Foxconn. They make iPhones, they make our batteries, they make air conditioners, they make refrigerators, and they make our batteries in Memphis, Tennessee. So, you know, this is a factory that you can come visit. These are systems that you can come and touch. And our company is headquartered just outside of Kalispell, Montana. So if anybody ever wants to come and see and meet the engineers and touch the hardware, we'd be happy to have those conversations and host you. We're going to get into what I call power and energy service versatility. And you know, the fact of the matter, as the ABB guys talked about yesterday with the 8 S's, when you have a battery in a microgrid, you're really looking for it to do 2 things. You want it to be able to do bulk energy load following and bulk energy shifting and renewable energy integration. That's what we would call an energy service. But you also want it to do power quality, grid forming, frequency regulation, spinning reserve type power services. And when you look at lithium-ion batteries today, and you go and you open up the brochure, as I'll show you in a minute, you really have to choose, am I going to buy a power battery or an energy battery? And in a microgrid, you want a battery that has the ability to be at top of state of charge, getting ready to discharge and provide grid forming services, or you want a battery that's at the bottom of the state of charge, getting ready to charge when the sun comes up, that can also provide grid services down there. And fundamentally, lithium-ion batteries with their 35-page poorly written warranties with all their trapdoors don't allow you to do both services from the same platform, and Vision is highly differentiated in our ability to do that. We've been highly recognized. You know, we're most proud actually of Navigant Consultants' recent report where they went into and ranked the 14 companies that are out there competing in the non-lithium world. They ranked Vision as the most competitive and most likely to succeed non-lithium ion battery company because we have significant differentiation around product safety, product cost, product OpEx, and battery versatility. So this is the versatility message. I'm going to try not to mark it for too long, and we'll get to the case study as much as possible. But when you open up the brochure from Tesla, Samsung, LG Chem, actually this image in the middle is exactly what you'll see. You'll be asked to choose between 3 different varieties of battery. You can choose from the power variety, which allows you to do things like frequency regulation and voltage support. These are short 15-minute to 30-minute batteries. Or you can choose from the energy variety, which allows you to do things like energy shift, curtailment elimination, types of renewable energy integration where you're absorbing kilowatt hours and doing deep discharges and deep charges. So, you know, the notion that a battery has the versatility in the lithium-ion profile to do both of these is a falsehood that needs to be corrected in terms of how we look at this technology and what we expect from it long term. And Vision is highly differentiated because we're a flow battery. The largest battery that we're building right now is a 2 megawatt battery. It's going to be connected to the Ontario Power Authority. It's contracted, and it's actually contracted for frequency regulation. So to have a flow battery contracted for frequency regulation, when I say that to people, most of them look at me like I have a third eye, right? Because it's not what folks expect. I stole this from the ABB guys. I told them it was coming. But these are the 8 S's that they talk about in terms of the 8 services that are required in a microgrid. And, you know, when you take a look at the power services and the energy services, You have a yes, we can do that reply from Vision. And from the lithium ion side, you'll have to either build a hybrid system using some power format and some energy format integrated into one platform that's going to drive the CapEx up almost 60 to 80%, or you can go with one versatile platform. We talked a little bit earlier about safety, right? And I'm sure that mine safety is important to everybody. And I've got a lithium-ion battery in my pocket. I was luckily able to fly here with it today. The fact is that, I'm sorry, I keep telling stories about members of my family, but in addition to my grandfather being in the mining industry, my father was the chief of the local fire department for 25 years. And in his office, there was a file cabinet, and we had a folder on every large industrial site. And in there was a list of all the chemicals, all the machinery, and a map of all the hydrants and what they were going to need and whether or not they would need neighboring fire departments to come and respond. In conversations with fire chiefs recently, basically the only planned response that they have for lithium-ion batteries is to protect the exposures and let it burn to the ground, right? There's no amount of wet water, there's no amount of dry chemicals that you can put on these fires to put them out. Dry chemicals essentially suffocate the fire, but when you remove the dry chemicals, the fire continues to burn until the battery is completely de-energized, right? So this is a significant concern. In addition, we are putting batteries right now along the Rhine River in Germany, and we're permitting these batteries in wetlands in highly environmentally sensitive areas. And we've gone through significant due diligence by the German Ministry of the Environment, by TÜV Süd, by Black & Veatch, to get to the point where everybody is super comfortable with placing our batteries without the need for expensive berms, without the need for secondary containment. And this is the kind of stuff that's relatively environmentally benign and really helps with permitting and siting and end-of-life concerns. On the right there is another key point, right? So anybody who's ever seen a large battery installation using lithium ion knows that it has a massive HVAC, right? Heating, ventilating, and air conditioning supply handler, right? So that it can maintain the internal temperature of the battery between 70 and 75 degrees Fahrenheit. Outside of that temperature window, you start to see accelerated decay in a lithium ion battery. And what's not talked about when these vendors are talking about round trip efficiency, they're not discussing the auxiliary loads of constantly running HVAC to keep the batteries within these ideal temperature windows, right? And they'll look you in the eye and say round trip efficiency is in the low 90%. However, when you start taking into account a warm weather site and you're loading in all these aux loads, you're really looking at round trip efficiencies on the AC side, which means the kilowatt hours have traveled in and out of the inverter in the 78 to 82% range for a warm site. And that's one of the key nuggets of the Black & Veatch report when they looked at Vision's technology, and it's quoted right here, basically that they believe that our systems outperform lithium-based systems at high temperature due to the fact that we require zero HVAC. The batteries themselves, they run at 130 degrees Fahrenheit, and they essentially, from an aux load basis, it's relatively negligible. Today's presentation isn't just about Vision. Everywhere we go, right, mining companies and utility companies and IPPs are always asking us for a turnkey quote. And so we're very fortunate to have with us today a 200-year-old company. CMI is a company, they're based in Belgium. They do business all around the world. Many of the clients we've talked to this week actually have known CMI for years based on their industrial activities and mining activities. CMI, together with Vision, offers a unanimous and single point of contact turnkey solution. I'm also pleased to announce that last week we had conversations with a financial lender who has said that if we find meritable opportunities for PPAs for these turnkey solutions here in Canada, they're looking to own and operate these systems. So to the extent that you're interested in connecting with us, we can give you both a turnkey cash quote, but we can also put together a PPA that should come close to lowering your annual energy spend. A lot of fine print here. Slides are attached to the link. We should have a full turnkey approach. Just so you know, this is a project that's under construction at the CMI facility, industrial facility in Belgium. It has solar, it has vision batteries, it has controls. The CMI team has been spending and investing significant application engineering and project management and field service and operation maintenance time and effort to be ready to offer and wrap these types of turnkey solutions. So into the case study. So this was an actual project that we were approached by. It was a gold mine in Burkina Faso, and we were fortunate to receive their complete loads. My application engineering team is led by a guy who's built 19 remote power solutions up in Alaska over the past 15 years. His company has been responsible for the complete EPC. He left his company 3 years ago, joined Vision, and now he runs our battery sizing, renewable energy sizing, diesel genset sizing, and overall economic modeling efforts. And so it's not his first rodeo, right? So this is just a good example of the kind of work that we can do for any mine. And it usually takes us anywhere from 3 to 5 days to turn around this analysis if you give us your complete mine loads. And we can give you a sense for the optimum sizing based on maximizing income. So this is an interesting site, right? Very high operating costs, about $5 million a year. When we put their loads into our optimization software, it spit out 4.2 megawatts of solar and a 1.2 megawatt battery with a 54% diesel and carbon reduction rate. And here are sort of the loads, and they're interesting. The red is the daily site load for any given day, and we've zoomed in here to the beginning of July. You can see on any given day that the solar essentially goes up and comes down, and then you can see the reduced output of the genset, right, during the middle of the day when the solar is stepping in. The genset is still there, it's in standby. Not all of the gensets are turned off, right, so you don't have the ability to significantly drive down hours on all gensets. You will still have the noise at the base camp, right, or at the generating station. And then we also took a look at what this looks like with the storage, right? And so you can see here it's roughly the same curve. However, you have the blue curve being the battery charge, right, during the middle of the day. And then you have the green curve being the battery discharge. And these are the types of curves that we'd be happy to generate for you and your site in our type of analytics that we do on a regular basis. But let's take a look at the numbers. Oh, how do I go back? There you go. These are the numbers, right? We looked at 3 cases: diesel only, diesel and PV, diesel PV plus storage, right? And we started to take a look at how can we use more of this super cheap fuel, which is solar, right? And the way you do that is by driving up the overall size of the PV so that when the PV exceeds the load of the facility, the excess goes into the battery, right? The next 2 slides look at a low cost of diesel delivered. So I think we had it at $1 a liter and then $2 a liter. And then we looked at the PPA rate of the blended solution for 5, 7, 10, 15, and 20 years. And this kind of dovetails with the last conversation, because if you take a good look at the 5-year offer, and this assumes that you cannot relocate the solar, right? And this assumes that the residual value of the solar at year 6 is actually negative because the deinstallation and decommissioning costs are significantly more expensive. Now, you could have 2 approaches to that, right? That, obviously you have a very creative hardware approach where there's residual value based on deinstallation, reinstallation, and contract extension. Or you could have the option to extend this PPA at year 4 or 5, Or the third could be an agreement with the local community to allow them to buy power for, the residual 15 to 20 years at 3 to 5 cents a kilowatt hour, which is a fraction of what they're already paying from some other source. So either way you look at this, there's ways to skin the cat on the back end, but this assumes that the residual value is actually negative at the end of the PPA term. And with diesel at $1 a liter, you start kind of seeing this break even at 7 years, and it really has to get to 10 years to really make sense from this set of calculations. However, when you go to the higher diesel scenario, it actually is interesting in the first, actually one comment. Even at 7 years in the low diesel cost scenario, the solar alone and the solar plus storage are at 27 cents a kilowatt hour, right? So it's an equal payment, equal price per kilowatt hour. Both of those are about a 20 to 23% reduction in your overall annual spend on energy and your overall annual spend or annual emissions targets, which is interesting. However, the storage approach would also give you the added benefit of having less diesel gen runtime, less diesel gen O&M, and the ability for the batteries to back up critical loads just in case all your diesel gen sets were to go down. It gets more interesting, just like the ABB guys showed us yesterday in those beautiful charts, and frankly, they left me running to want to redo my presentation last night because it was such a nice job that they did. But the higher diesel environment is even more interesting, right? Because it essentially suggests that even a 5-year PPA with no residual value at an elevated rate of something like 45 cents compared to the 62 cents a kilowatt hour that the mine is currently paying is a significant reduction in expense. And if this can be capitalized by a third party and not treated as an asset by the overall operating company, which is the mine, then it's cash flow positive in year one, right? Without the need for residual value or optimized relocatable solutions that can actually take these numbers and reduce them even further. So in summary, right, significant opportunity here, significant availability of creative solutions both on the battery side, that's highly differentiated to go with the unique solutions on the solar side. When you look at your battery, I urge you guys to really start thinking about the total cost of ownership, the performance of the battery and its ability to do versatile power and energy services from one platform, and a platform that does not have significant environmental health and safety concerns for ease of permitting and overall general community friendliness. Thank you.